Hello students and viewers, I take this movement as prestigious one. This is Gopal from Department of Chemistry, Bharathidhasanar Matric High Secondary School, Arakkonam. Today we are going to see 11th Chemistry 6th unit and our today topic is Gay-Lussac's law. So students, we already discussed about the gas laws, especially Boyle's law, Charles' law, Gay-Lussac's law and Avogadro's law, in which the Boyle's law and Charles' law closely related to the volume, temperature and pressure. So today we see Gay-Lussac's law with the relationship between pressure and temperature. So what will happen for the gas molecules when we applying pressure, and what will happen for the gas molecules when we applying temperature. So the relationship between pressure and temperature, by varying one things, what happens for the another term, we will see today. Let us consider a container which is filled with the gas molecules. When the container is heated, the temperature inside the container is increases. So the temperature increases. As per the temperature increases, the pressure also increases. So in which, according to Gay-Lussac's law, the relationship between temperature and pressure only noted. So the temperature increases, the pressure also increases, because when the temperature increases inside the container, the gas molecules absorbs the heat. When the gas molecules absorbing heat, the molecule attains the kinetic energy. So the kinetic energy of molecules increases with the temperature. So when the molecules attaining kinetic energy, it randomly can get motion and it can move from one position to another position, because due to its kinetic energy, the attraction force between the atoms breaks. So molecule can easily move from one place to another place. So the random motion causes for the collisions. Due to the collisions, the container gets higher pressure. So the pressure is nothing but the collisions between the walls of the container and the molecules. So due to increase in the collisions, pressure increases. So Gay-Lussac's law finally describes about the temperature and pressure relationship. So in Boyle's law we discussed about pressure and volume relationship. When we increasing pressure, volume decreases. So pressure is indirectly proportional to volume. So Charles' law describes pressure and temperature. When the pressure increases, temperature also increases. So how can we write Gay-Lussac's law in examination? The pressure exerted by a gas is directly related to the Kelvin temperature. So pressure directly proportional to temperature. P directly proportional to T is the Gay-Lussac's law. When we are applying the constant P equal to KT, here K is the proportionality constant. So this is a mathematical representation of Gay-Lussac's law. By knowing this mathematical representation, we can apply the different pressures for the chambers. If you are applying different pressures in the chambers, the first chamber contains T1 and the pressure P1. Second chamber contains the temperature T2 and its pressure is P2. So two different pressures and temperatures applied for this container. So the formula, general formula can be written as P directly proportional to T means P1 directly proportional to T1 and P2 directly proportional to T2. So it can be combined in a single equation, means you can get P1 divided by T1 equal to P2 divided by T2. So this is the mathematical representation of Gay-Lussac's law. By knowing these laws, you can create the ideal gas equation. So now we see the creation of ideal gas equation. Ideal gas equation simply denotes by first the Boyle's law. Boyle's law describes pressure indirectly proportional to volume, and the Charles law describes volume directly proportional to temperature. Third one, Avogadro's law. According to Avogadro's law, V directly proportional to number of moles N. When we combining these three gas laws, we can get a ideal gas equation. So, see the students, in which the volume is indirectly proportional to pressure and it directly proportional to temperature, and volume directly proportional to number of moles N. So, V equal to R into T N divided by P. Here the R is introduced to balance this equation. When we applying equal, we can put the constant R. Here the R is for the gas constant. R is gas constant. After applying the gas constant, we get the equation V is equal to R T N divided by P. This is the ideal gas equation. We can write this in another form, P V equal to N R T. It is the general form of this equation. So, ideal gas equation is obtained from these three equations, Boyle's law, Charles law and Avogadro's law. So, which are the gases obeys these three laws, Boyle's law, Charles law and Avogadro's law, means that gases are called as ideal gas. So, ideal gases are generally obey these laws, Boyle's law, Charles law and Avogadro's law. So, this equation is responsible for especially for ideal gases. In some cases, sometimes nitrogen, oxygen, chlorine, such a gases can behave like a ideal gases. So, ideal gases do not get interaction between the molecules, but the real gases get an interaction. So, how the formula will be changed for real gases? It is described by van der Waals. So, in the next video, we will discuss about van der Waals equation, especially for real gases, how they are differ from ideal gases. So, students, in the below description, you have the study material and self-assessment question paper. Write the subject note, the book bag 2 mark and 5 marks, and self-assessment test if you write means get a correction. Thanks for making time to watching this video. Thank you.